device that allows us to easily figure out the speed of very small objects. It's called a ticker tape timer. Try saying that 5 times fast. So, sometimes called oil drop diagram. The reason is because they look like the trail that would be left behind a car if it was leaking oil. So, if you're leaking oil, and you're driving you're just driving normal, you're driving fast, you don't know your car is leaking oil, what will the trail behind you look like? Would you see a lot of oil on the floor or a little bit? Right, because you're moving so fast that there's a lot of space between the drops of oil, okay? Or you see a thin little line, right? But if your car was moving slow, the drops of oil that you leave on the floor are going to be much closer together. That observation gives you information about the speed of the car. You can look at the oil trail and you can say, okay, this person was driving very fast. They probably didn't know that car was leaking oil. Or they were driving really slow. They were probably being careful. They realized their car was leaking oil, so on and so forth. The ticker tape timer, it works similarly. But instead of oil, what it does, it has a little needle that makes dots on a strip of tape, not like sticky tape, like a thin, like a piece of paper. And it makes a mark on a piece of paper every 50th of a second. Okay? So if we pull it through, if we pull the piece of tape for 1 second, it'll have 50 dots on it. So that's very, very fast. So every 0.02 seconds, it makes a dot on the paper. And depending on how fast the object is moving, how fast the tape is being pulled through, the tape is attached to the object, okay? Then we can look at the tape and analyze the motion of the object. So if we look at these ticker tape diagrams, let's talk about the motion that's represented by each. So for this first, I'm going to call this one number 1. This object is moving at constant speed. How can we tell? Well, every dot is just as far behind the previous dot. Exactly. They're the same distance apart. Okay? So when the dots are equally spaced out, then we can't tell if it's going fast or slow. Well, I mean, we'd have to compare it to something. Okay? But we can't tell that because the dots are equally spaced, then this object is moving at constant speed. What can you say about the beginning part of this tape? How is the object moving during this time? Number 2. Exactly. It's moving slow at first, and then what happened? How can you tell that it started to speed up? What are the dots doing? Very good. So the spaces between the dots increase. So that means that the object is moving faster. So when we're moving at a slower pace and we speed up, that's called acceleration. Okay. Compare it to number 3. Number 3 is also accelerating, but this one is accelerating at a much, much faster rate. Okay, so number 2 is sort of a gradual speeding up. Number 3 is a very like instantaneous acceleration. So it started off slow at the beginning and it sped up. The space between the dots increased very, very rapidly. Okay, so it's not a gradual, right, very slow and then very, very fast. Okay, so it changed speeds very quickly. Now, how can we tell the speed of the object by just looking at the tape? What do we need to know to calculate an object's speed? What's the formula for speed? Exactly. We need to know distance and we need to know the time. So how can we find out the distance? Well, the distance the object traveled is the length of the tape from the first dot made to the last. So the length between the first and last dot gives us the distance traveled. Okay. Then the time, we just measure the ruler. Okay. So we'll measure the tape in centimeters, millimeters. Okay. Now the time. Remember that machine, that needle goes down every 0.02 seconds, no matter how fast or slow the object is moving. Okay? The needle is going to go down the same time, in the same time intervals. So if we want to know how much time passed, we need to count how many intervals or how many spaces are on the dot. So from the first dot to the second dot, that's 0.02 seconds. In another 0.02 seconds, the ticker makes another dot. So the space between the second dot and the third dot means 0.02 seconds has passed, and so on and so forth. So if we want to find out the time, count how many spaces, and then we multiply that by the time interval, 0.02. Now for BGCSE, this is not going to change. This is pretty standard. So 1/50th of a second, that's the time, 1/50th of a second. And if we write it as a decimal, that's 0.02 seconds. Okay, so every space represents 0.02 seconds. So for this tape that we're looking at, let me just clear this up. For this tape that we're looking at, how much time has passed? Exactly. Okay. 1, 2, 3, 4, 5, 6, 7, 8 spaces multiplied by 0.02. That works out to 0.16 seconds. Okay. Let's look at a question. Oh, this is our formula. Okay, so we are adapting the velocity formula, our regular velocity formula, and instead of distance, we're going to write length of tape. So that gives us the distance. This is not a whole new formula that you have to use. Okay, we're just applying it to this particular situation. So the length of tape gives us our distance, and the number of spaces, that should say multiplied by the time interval, which is 0.02, so I'm just going to put 0.02. It's going to give us our time. Okay? All right, question. Say that the tape shows that the trolley speed is constant. So we have a ticker timer diagram. This part right here tells us that the time interval is 0.02. The ticker timer puts a dot on the tape 50 times a second. Okay? That translates to 1/50th of a second, or 0.02 seconds. Okay? So just looking at the tape now, before we're not doing any calculations just yet. I just want to know how the tape shows that the trolley's speed is constant. What can you say? Very good. The dots are the same distance apart or equal distances apart. Okay? I would use the word length. Okay? We're talking about this distance between dots. Okay? So dots equally spaced. All right. So the figure shows us a full scale diagram. Um, a full scale diagram of a ticker tape attached to a moving trolley. We have a scale with 2 millimeter divisions that we're going to use to help figure out how long our tape is. Okay? Sometimes in the exam, if they don't give you a scale, then you use your rule and you literally measure it. Okay? Because I've seen a question like that before. But what we want to do is use that same velocity formula that we adapted to this to determine the speed of the trolley. So if we just scribble our velocity formula in the corner here, distance over time, first thing we have to find is to find the distance. We're going to do that. Well, we're going to line up the beginning of our first dot with the end with the tape, and we're going to do the same thing at the end of the last dot. That's not an exact, that's not a really straight line. Back. Okay, let's line that up properly. Okay, and then, yes, we have to count. Each of these little boxes is 2 millimeters. So we have to find how many divisions span the length of our tape, and then we multiply. Tell me how many divisions you counted. I counted 53 too. So 53 divisions, and each division is 2 millimeters. So that works out to 106 millimeters. that's our distance. Okay? Now the time, how do we find the time? Tell me how we find the time. 11 what? Number of spaces, right? We count 11 spaces. Good. I counted 11 spaces too. And we multiply that by 0.02 seconds, which is going to give us 0.22 seconds. All right. Awesome. Okay, guys, you did some good work today. Good calculation.